Okay, afternoon, guys. Another week, 2 weeks to go before half term, so we're not far off. Now, just a bit of information before we start the lesson. As you're aware, we'll be doing some tests after in maths. I think in all subjects to be after half. What information will basically it will be pretty much the A level content. Everything we've done, one and book two, and statistics and mechanics. Okay, now we might do a further maths paper as well. That's still to be assumed happen. Okay. Also, a few of you still got a little bit of work to upload on OneNote. Please make sure you. Right, we're going to start the lesson as we always do with a starter. Now, these questions are A2 content, not AS, so they should be a little bit harder. I think you should try and do these in 10 minutes. These activities really important. Vision and to keep fresh to get this stuff. Okay, so I'm going to give you 10 minutes on this. If you need a little bit longer, though, do pause it time. Okay, right, guys, ready? Off you go. Okay, guys, that's about time. Let's just quickly run through these. So the first one, I'm just going to, because these are slightly hard, I'm going to give you a few tips on these. So the first one, you need to look at this right-hand fraction, and because it's a stack, this is called a stacked fraction. You've got a fraction within a fraction, times every term by x plus 1. So you get 2 over x minus, so that's going to be 3 x plus 1, and then on the bottom you're going to go 1 minus 2 x plus 1. And then if you multiply that out, simplify it all, get a common denominator, you should end up getting to there. This one here, you need to start by doing algebraic division, and then you're going to split it up and see, hopefully get the right answer there. Algebraic division, you can either do it like this, or you can do the FAS method, or comparing coefficients. But doing this way is good because you know there's going to be a remainder there. That's going to be your, and hopefully you get an answer that's to that. Okay. And then the final one here, this is the product rule. This is a function times a function. So you should say u is equal to e to the sine x, and then v is equal to cos 2x. If we differentiate each one, this one's sort of a chain rule, differentiate that, that's cos x. That's going to be cos x, that stays the same. And then if you differentiate v, you get differentiate that to negative 2 sine 2x, and then you use the formula, and you should end up getting to that stage there. So just take a bit of time, guys, on that. It's important that you do that slowly. Make sure you understand what's going on for those questions there. All good revision. Okay. Right, today we are carrying on with Argand diagrams. Okay, so the date today is the 12th. So we're doing Argand diagrams. Continued. Okay, and we're specifically looking at the modulus argument form of complex numbers. Okay, specifically looking at them. It's a different type of writing complex numbers. Now, what we've learned up to this point is a complex number, usually defined as z, is equal to some real part plus some coefficient of the imaginary part. Okay, and that's a Cartesian form. It's a Cartesian form of a complex number. Now, there are different ways of writing that, and they've all got different benefits. And we're going to just look at a different way of writing now. Now, if I was to put that on an Argand diagram, imaginary, real, so it would slot in. Let's just put it in here. Let's call it I. That's what z is. I'm just going to call the length of that complex number, or the modulus of it, the height of it there. Well, that must be y, because that's the coefficient of i's, and x must be in there. And then just for definition, I'm just going to call that theta. So on an Argand diagram, I'm just going to say it goes there. Now, it could have been in all 4 quadrants, but I've just put it in there just for ease for now. Now, so if we say, okay, well, z is equal to x plus yi, we know that. That's what we just defined it as. Now, I could also write that, or x here, well, that's the same as, that's the adjacent, isn't it? So in terms of r, x is the same as r cos theta. Okay, and y, well, that's the height of that right angle triangle. It's a right angle triangle. That's going to be r sine theta, I. Okay, now that is mod arg form, modulus argument form, sometimes shortened to mod arg form, because you've written the complex number in terms of its modulus r and in terms of its argument theta. Remember, the argument theta is usually between pi, negative pi. Okay, so I'm just going to tidy that up a little bit. We usually factorize out the r, and that's going to be cos theta, and that's going to be, we normally put front sine theta. So that is the official generalized way of writing complex numbers in modulus argument form. Okay, right, let's look at an example, straight in with an example. So let's say the complex number z is negative I, express z equals negative in the form r cos theta plus theta. Okay, now just to go back, there are uses of when you would want it in this form rather than the other form, which we'll come on to later. But for just this lesson, we need to be able to fluently work between the two. We'll certainly go from Cartesian to mod arg form. Okay. Right, now step one here, always draw the Argand. Really helps you visualize what's going on. So draw the Argand diagram. So imaginary, real in there, and negative 1 goes. So negative 1 and negative I will be the same as negative 1. Let's put, that's where it would fall. Okay. Now remember, r is the length of that line, and theta, well, that's the argument. Now remember, the argument's this way. That's going to be theta, and remember, it's going to be negative because we're going clockwise. Right, so I need to work out two things here. I need to work out r, the modulus, and that's quite easy. That's just Pythagoras. R is equal to square root 1 squared plus 1 squared. R is going to be 2. Now the argument, theta, I'm going to work out alpha first. So alpha is going to equal, okay, this is tan minus 1, opposite over the adjacent, which is also 1. And if I do that on my calculator, so it's in radians, luckily. Let's just shift 1, yep, pi over 4. So pi over 4, we should know that anyway. So the whole of theta is going to be, well, 90 degrees, which is pi over 2, plus pi over 4, which is going to be 3/4 pi, 3 pi 4. Now just be careful, because it's the argument, it's actually going to be, so it's actually going to be negative that, because we're going clockwise round. Now I've got r, now I've got theta. My final answer is pretty straightforward, because minus, so you've got minus 1 minus I must equal root 2 cos negative 3 pi over 4. So just up here, it would make it very clear that theta's got to be between pi and minus pi there. Plus I sine negative 3 pi over 4. Okay, so that's my final answer. Now let's just check that my answer is correct. I'm going to use this on my calculator. Now I didn't show you this last time, because I only figured it out myself recently. If we go menu complex mode, I'm going to type in my complex number, negative 1 plus I. Remember, I is the end by there. Okay, actually it's minus I, sorry. I need to just go back. Minus I. And then minus 1 minus I. Okay, right, there it is. Now if I go option, I can get the argument, I can get the conjugate, real part, imaginary part, but I can also go down one and press this button. Number 1 will give me r, which is the modulus, and the argument. It's pretty useful. If I now press 1, I get root 2, and that's the argument. Root 2 goes there, that's good. And the argument is minus 3/4 pi, which is great. I know that's correct. I could have actually worked backwards. If I put in root 2, tried this because negative 3 pi 4 plus I, putting it in this form, 4. Okay, sorry, I need to... Okay, now let's see if I press equals, hopefully it gives me it straight away. So that's, again, I can just plug that in and it gives me it immediately in the Cartesian form. So I can check all of these answers on my calculator. Extremely powerful tool. Okay, so do always make use of that when you're doing these questions. Right, what I want you to do, that's the end of today's lesson, is exercise 2C, question 1A and H, question 2A and C, question 3A and F, and question 4 to 6, all of those please. Use the calculator to help you. Please do upload any workings to OneNote so I can just keep a track of how you're doing. Okay, and I will see you on Thursday. It'll probably be another video on Thursday carrying on with Argand diagrams. But if you've got any issues today, sorry, I'll be on Teams in the chat. So if you want any questions answered, please do log on there. Speak to you. If not, I'll see you or speak to you again on Thursday. Well done, guys.